Signal mode. Frequency mode.
All right, are you ready?
Mm-hmm.
All right, let's get started. We're here because a lot of people, as we ask in Elmer sessions and surveys and whatnot, what people are looking for, what they need to know. And one of them is, I've got my license, what do I do now? And based on the number of extras that raised their hands a half an hour ago, I'm thinking a lot of you know what to do now, but people have asked for this, and I'm also trying to make this something that we can publish to the website, so you'll find the slides are very verbose. I will do my best not to read the slides, but I wanted to make sure that when someone downloads the presentation and reads it, that it makes sense. So there's more text on the slide than you would normally have in a good presentation. As you can see, we have a bunch of things on the agenda. If you have a question about something on the slide, please raise your hand, speak up, whatever. But I may say, hang on a minute, we've got it coming. To that point, let's get started. This is about what you do once you get licensed, but here's a quick plug. If you know anyone that isn't licensed and wants to get licensed so that they can use the rest of this presentation to their advantage. RARA teaches license courses. You heard about those earlier. The ARRL sells a license manual that we use in the license courses. Great source of information. So is the regular ARRL manual. Online practice resources. I never recommend that people use the test questions and memorize the answers, but they are a great self-education opportunity. When you read a question, all of the questions on the test only have one answer. There's no multiple correct answers. So you know that one's right, and you know that 3 are wrong. If you can say why the other 3 are wrong, you've used that test question as a good learning opportunity. There's 2 sites there. I've used the QRZ one. It didn't require a sign-in in the past, and hamstudy.org is very popular. There are also others, but there's a couple examples. And again, another plug for the Elmer's Corner here. If you have something that you're not quite sure about, or one of those questions, hey, I really don't know why question or answer B is better than answer C, bring it to the Elmer's Corner and we'll get you an answer. And of course, we want to make you a ham 3rd Saturday of, I say most months, because in the middle of summer we don't do testing. But we do free license testing on the 3rd Saturday of most months. All right, let's get to it. If you're a new licensee, you're probably operating in VHF or UHF. This is the ARRL band chart. There are frequencies in other parts of the chart down in HF that technicians may also operate on, but they are either CW or they are sideband, which makes them less popular for technicians. Also very, very narrow segments that technicians can operate. So we're going to focus on the 2 most popular, 2 meters and 70 centimeters. So you've got your radio, you turn it on. Squelch. Squelch is easy. Squelch, you turn the knob up until you stop hearing that annoying noise. And then, as is sort of indicated in this diagram on the upper right, you adjust it so that you can hear the things you want, and then when someone stops transmitting, instead of hearing noise, the radio goes quiet. That part's pretty easy. It gets a little more complex when you add in tone, PL tone, CTCSS. All of these names essentially mean the same thing. And what your radio is doing there is it's adding in a frequency that doesn't get sent through the speaker that tells the receiver hey, you need to open up. So it's not just the signal strength that's telling the remote receiver to open, it's also this additional tone that gets sent in with your transmission. So there's a bandpass filter. You can see to the left of the line are where PL tones are. And to the right of the line is where your voice audio, 300 hertz to 3,300 kilohertz, is sent to the microphone. So this is sort of used as an in-band signal that just never gets played out the speaker. And that's really good in RF dense areas. It keeps interference from triggering either your radio or especially repeaters from transmitting just because of interference. DSC serves the same purpose. It's not really popular. It's just a digital code that's sent in the same way, but I'm not going to cover it any more than that for the purposes of this. Simplex operation. Simplex is really simple. You set your radio to a frequency, I set my radio to a frequency, and if we don't set other things like tone squelch, we can talk to each other. A lot of technicians go out and buy, and rightfully so, I did the same thing, a 5-watt handheld transceiver. 5 watts can get you pretty far, but 5 watts also suffers from a lot of simple obstructions like mountains and trees and buildings. So there are some distance limitations. Anyhow, on Simplex there are some really common frequencies. As you can see here, these frequencies are pulled from the ARRL band plan. Calling frequencies are where you get on and call for a contact in Simplex. Also, this one here in the middle, 146520, probably the most common frequency for someone to monitor. So if you see a ham driving down the road, you know, because they're those goofy people with the antennas on their car, you can probably reach them at 146520. Now those are calling frequencies and they can get busy, so if you talk to someone there, move to one of these other Simplex frequencies. And you can do that by saying, hey, let's move to 147420. You don't have to use it in I think people will say it's frowned on to use Q codes, rating FM 2 meters, 70 centimeters. Just say what you want to do in English, and also if you're planning to make a contact, plan it off of one of those calling frequencies to leave it open for calling. Repeaters. So I talked about 5 watts not going very far, and especially if you're standing on the ground next to some tall buildings. So repeaters come in to solve that issue. For example, I'm going to use, in a lot of my examples, the K2GXT repeater because I'm familiar with it. It's on the top of Ellingson, which is I'm pretty sure the tallest building on RIT's campus, and it has a 6 dBi gain antenna. And the result of that is that it's up really high and puts out about 160 watts. Yeah, Jim? Yeah. So 160 watts up really high does a lot more than what you could hold in your hand. So as you can see in this crafty diagram taken from Wikipedia, it solves that obstruction issue. And with a bigger antenna and more power, it also covers more geography. So for example, with my 5-watt handheld transceiver, I could easily reach that repeater standing right here. However, if you were standing somewhere on RIT's campus with my 5-watt handheld transceiver, because we're in this building and RIT has a lot of tall buildings, you might not reach them without going through the repeater. We'll talk a little bit more about TX and RS offset. The important part from this page is to realize that a repeater is listening and retransmitting the same thing, usually through a device called a duplexer that lets it use the same antenna at the same time without blowing itself up. We're not going to get into repeater topology from the RF side much more than that, but we will talk about offset because it's important in programming your radio. Repeaters have a controller. It's a piece of hardware. A lot of repeaters have more than one transceiver. For example, a repeater might have a 70 centimeter transceiver and a 2 meter transceiver. So the repeater controller manages the interaction between those two radios. It also does the job, repeaters are radios, they need to identify themselves, so it does the job of providing station identification, and it can interface with non-radio devices, the most popular of which are various internet communication modes. I'll try to use the most generic term. The most popular of which are the Internet Radio Linking Project, IRLP, Echolink, and All-Star Link. So the repeater controller interfaces the transceiver and the repeater with some sort of computer that can be on the internet. I think I talk a little bit more about commanding those. Yep, I do on the next slide. So, DTMF. Let's go to the keypad. On your radio, if you're holding the transmit button while you push the keypad, if your radio is so equipped, you will send DTMF tones. It is the same, or very similar to, sending DTMF tones from a touch tone keypad. Those tones can be used to control the repeater. So I just said that a repeater can be connected to the internet. If you want to connect a repeater to the internet or to a remote internet node, you key up and you dial a key sequence. For example, at RAT, telling it you want to dial up an internet node, you dial *3. And then there are various codes you punch in from there to tell it where you want to connect to. I think that's good for DTMF. Obviously, if you're not transmitting, your keypad does different things. Most radios, you can at least use it to dial in a specific frequency or memory you want to use, and to manipulate tons of other settings. Most of today's HTs that are equipped with a keypad also have a deep, complex, and confusing series of menus that most people ignore. But you can get through all that and set every imaginable possibility on your radio through that keypad. Though I don't recommend it. More on that soon. Should you need to program your radio, and you will, here are the key items you'll need. You need to set a receive frequency. If you're operating in Simplex, this is the same frequency. So if you're using one of those Simplex channels we mentioned earlier, it's also your transmit frequency. If you are using a repeater, or there are certain other cases, but let's limit it to repeaters here, you will also need a transmit frequency. Now, most modern radios, if you tell it to listen on a common repeater frequency, that radio will automatically set itself to transmit at the appropriate offset for the input of that repeater. And we'll talk a little bit more about that later. But I'll give a quick example. If you set your radio to 147.075, that is a common repeater frequency in terms of the ARRL band plan. Most radios will automatically set a plus 600 kilohertz shift on that, so that when you key up, your radio will transmit on 147.675, which is where the repeater is listening. So most of that happens automatically, but it's important to know what those are, and when we get into the programming software later, you'll see that spelled out more clearly. Squelch mode. Your radio, you can set the squelch on however you want. Many repeaters require that you send CTCSS or PL tone. So that would be the second case here. The other option is tone squelch, which means you're going to transmit tone that will tell the remote repeater to open, and you're going to require tone back. Not all repeaters transmit tone, so that doesn't always work, but many do. And in dense areas, it's very popular. And so you turn the tone on, then you need to set a tone value. Around here, most radios are 100 hertz or 110.9 hertz. Common repeaters around here we'll get to later, but let's talk a little bit more about programming. I said before, I don't really recommend programming through the keyboard or keypad. It's tedious, it's really tedious, and it's error prone. So you're scrolling around and you set a frequency and you key in the frequency 1 digit off, and then you press save and you overwrite the wrong memory in your radio. I really don't recommend it. It's much easier to use a computer to program your radio, and you really need mostly, generally free software, which we'll get to, and some relatively inexpensive hardware. So here I have a programming cable. I forget what that one's for. I have two here. These were about $20 a piece. One programs Yaesu mobiles, and one programs Yaesu HTs. You'll notice both of these are serial. It's very much popular now to find USB programming cables, as in the diagram, but should you have a cable already or acquire one that's serial, you can buy a USB and a serial adapter. It's important to buy a good one. The communication between your radio and the serial port is very precise. So you want to look for a cable that costs probably $12 to $20. You can spend up from there too to get better featured cables. But if you're spending $10 or less on a converter like this, you're probably not going to be successful when you go to program your radio. So altogether, if you buy the two parts separate, $30 to $40. Or find someone else who has one for free. Software. Probably the most prolific is Chirp. Chirp is free and it supports tons and tons of radios. Let's walk through this to fit them on the page. I kind of did it out of order. If you look on, let's see how this goes. On the right side here, when you click radio, you can click import from radio. So what I like to do is bring in the settings from the radio, modify, and then send the settings back to the radio that have been modified. So I select my serial port, my radio model, and brand. Now here's the key. Chirp gives you instructions on what to do. If you don't follow them, you'll be like me and you'll be really mad at your computer for a while. The key is it says, after clicking OK, here, press the band key on your radio to send the data. So I pressed OK and then I said, why isn't it sending? What's going on? But there's no window there anymore. So read again, execute. This stuff works. If it's not working, well, chances are it's operator error. In the software, when you go to program, you'll see earlier we talked about frequency. In the case of Chirp, they don't list a transmit frequency. They just list the shift and the offset. So that example I used earlier, you can see 147075. There's a little blurry out there. Trust me, that's what it says. If you key that in to an empty line, Chirp will automatically set the offset and the duplex for you. What it doesn't have any way to know is a friendly name or the tone mode or the tone. More on all of this data later, but those are really the key items that I mentioned earlier. Now Chirp is, yeah?
Quick question on the COM port. How do you know which COM port to use?
Click around until it works. A while ago, your PC probably had 3 COM ports. It probably doesn't now. I say that, what I just said, sort of sarcastically, but sort of not. So my current computer only has 1 COM port until I plug this in, and then it has 2. So I just always assume the onboard one is COM 0, and this will be COM 1. Sometimes they get reversed. It really depends on how Windows feels when it starts. And I meant to, I'll get there. I meant to plug this into my Mac and try it out, just so I could demonstrate it, but I ran out of time. But really, you can dig into the device manager and find out what COM port is mapped to what serial device. But if you only have two, try twice. It's faster than finding the device manager. Hang on, go.
You just mentioned what I was going to say about device manager. Because with a lot of ports up, I have device manager, and when I plug in the cable, it shows me.
Oh, that's a good point. If you watch for the difference. I didn't think of that.
And it shows you what COM port it is, and then you go back to your software. And that COM port.
And you can also, if you find it's wandering, Windows will allow you to set them. If you dig in the device manager, you can change the COM port, and it will mostly stay where you put it. Again, if you plug in a new device, it may not.
Yeah, and if you have multiple COM ports, if you plug it into a different COM port the second time, it may assign a new number.
Yes, so every time that you plug this into a USB port, so you have a 4-port USB hub, every time you plug this into a different port, Windows sees it as a different device. So you've got COM 0, 1, 2, and 3 by the time you've plugged it into every port.
Just going to say, if you have a Mac or a Linux machine, just do an ls on /dev /gty asterisk, and then plug it in and do it again, and you'll see the new device show up. It's the simple one.
Chirp is great. Again, it supports tons and tons of stuff. I have a VX7R, and I prefer VX7R Commander. The reason for that is additional features. So we have all of the, you can see in the background here, all of the frequency programming, very much like Chirp. Pretty much any programming software, you have to have these things, right? Offset frequency and so on, so they'll all be there. VX7R Commander, you see I can also set up other types of memories because the VX7R supports some advanced features where you can program memories that include features of the radio beyond frequency and tone. Additionally, outside of those memories, you can also program a bunch of stuff that's buried in the menus of your Yaesu radio. So in this particular example, I clicked display setup. Now normally you would push some buttons on the front and rotate the knob and push some different buttons on the front. Here I can see I'm setting up my LED, what my meters look like. This interface is so much easier to use. At least I personally only own Yaesu handheld and mobile, so I can't speak to it. But most of these small radios have tons and tons of features, and they're super hard to manage through their physical interfaces. And the last example is sometimes you just go and buy the software. I don't know how much this costs because I bought this with the radio years ago, but this is a proprietary piece of software from RT Systems to program an FT8900. And this is the same case where I have advanced features that I can set in the software that was defined for that particular radio.
Just a heads up, the RT Systems software version 4 and newer, they lock the software down that you have to use their programming cable with it. So they burn the manufacturer into the USB to serial chip in the cable. So if you're using a generic cable that's not branded as an RT Systems cable, it's not going to work. That's what really turned me off from that software.
Yeah, definitely when I bought this, that wouldn't happen because I'm pretty sure in the head shell for this one, it's just, there's no logic in here, and everything was serial at the time. I can see both sides to that, right? They want to lock it down, they're like, oh, they want to lock it down so they make money. The other side of that is, especially when these devices became popular at first, there was a company called Prolific that made a chipset, and then there was a company in China that made 700 billion copies of it, and they did a really bad job, and then it gave Prolific a bad name. So sometimes companies like RT Systems will do something like, what Prolific actually ended up doing is they wrote their latest driver to disable every old Prolific chipset, even if it was a genuine one. And that's to try and keep up quality control. So there's sort of two sides to it, but that's definitely a valid point. They do charge a little more for their cables. It should be a better product. go for these old serial ones. Because they can't check for firmware on an old serial cable. One last comment, I didn't put it in the slideshow here. With the VX7R Commander, if you want to do something questionable like freeband your HT, you don't have to break it open and cut wires. There's a menu and you just hit a checkbox and save. It's cool if you want to be able to do things you shouldn't. But I don't recommend it, so it's not in the show. All right, so there's 3 pieces of programming software. You have a radio, you know how to transmit, you have all this software. What do you put into your radio? We have a CSV file on the website under, that says LUR links, because I typed it wrong, so I'll have to fix that. The CSV file you can load into Chirp, and it has all of the Greater Rochester area repeaters and offsets and tone and such in it.
It's learn_links.
Yes, learn_links, not lur_links. When I publish this, it'll be in a PDF format that you'll be able to click on that, and I'll get the link right before I do so. Also, if you're traveling, and you want to go and use radios somewhere else, I have 2 recommendations here of places that you can look up local repeaters where you're going. Additionally, this is another plug for using computer programming. So say I'm from New Hampshire. Say I go back to New Hampshire, and on my way I'm going to be in eastern New York and Vermont, maybe Massachusetts and New Hampshire. That's probably like 75 repeaters I'm going to pass by. If I had to program those by hand, I wouldn't do it. But if I can copy and paste out of a website and into an application and click send to my radio, well then it makes sense. So I get a better amateur radio experience, more operating time, for really a minimal expense in programming tools. Oh, and the last thing to put in there, early on in the slide are the calling and simplex frequencies. And those simplex frequencies on the early slides are a range. So yes, you can sort of just dial back and forth through them, but you can't program a range into your memories. If you Google, I should put this in there too, if you, the ARRL publishes a page where they've sort of channelized those ranges so that you can program a bunch of memories in and know that you're pretty likely, if you dial to one of those, to not be halfway overlapping with someone else. Was there a hand? Yeah.
Chirp can also access online databases for repeaters too. So you can query, I don't know if it's, I think you can do repeater book,
Yes.
and I think you can do radio reference if you have an account on there.
Yeah.
But it can query those, and it can also pull down like stock configurations for FRS, GMRS mirrors, things like that and other stuff.
Ooh, so that reminds me also, I'm not a Chirp expert, but I wanted to share this, and maybe someone who's had more time with it can say something about it. I said earlier that VX7R Commander gives me access to advanced functions in my particular radio. Chirp has this properties button. I have no idea what it does. I don't know if there's secret sauce in there or what.
Well, I know on the left-hand side of Chirp, you have the tabs on the left, which are, yeah, over there. Depending on the radio, I know, like the Baofeng radios, there is a third tab, second and third tab, that you can set a lot more options in for the menus of the radio, your IDs, things like that. You can also, if it's a new enough firmware on the radio, you can set your squelch thresholds. Squelch thresholds from the manufacturer are pretty crappy. Generally, the consensus is start at 0 and go up 8 every time. So squelch level 1 would be 8, squelch level 2 would be 16, and so on. So it's just pays to just dig around in there and see what you find.
Excellent. I'm happy that I brought that up because now we've all learned something more. And that makes it clear why Chirp is so popular, right? I've used it with one radio, but obviously because it's right on there. If you click this link, they literally support 100 different models. So with all that support, I'm not surprised that my older radio, it doesn't have full feature support, but it's still very good coverage.
The other nice thing about Chirp is if you have 5 different radios, you get your programming correct on one radio, you can then copy and paste it into different tabs, and it makes setting up all your radios identical real easy. Obviously, if some radios have 128 memory channels and some have 1,000, those might be a little different, but for similar, if you're gonna set up your same channels on a few different radios, you can do that. I also recommend donating to them if you have a few bucks to spare. Keep the project going, because there's used to be like 2 or 3 people working on it. Now he's got an entire volunteer crew keeping this thing updated. It's actually pretty good.
Yeah, any open source software like this, actually, it's not really fully open source, but any software project like this where stuff is free, it's still people's time and livelihood. So a couple bucks here and there from a bunch of people, it helps them out a little bit and makes it a little bit more worthwhile, especially if you have an older radio like I do or an obscure radio and you want to show some appreciation for their work.
Yeah, I just wanted to say, whoever did the CSA file, thank you, but it works with RT systems, because I programmed the ASU and ICOM radios with that CSV file as well, not only just Chirp. It works great.
I'm happy Scott stopped recording, so these pauses where I take all these notes don't get included. That's great. That's cool. I wasn't sure, CSV is pretty generic, but I also didn't know, like column alignment and how that changes between
Well,
vendors. So.
it takes you through some menus and you can highlight which columns you want to pull over from that CSV.
So if you couldn't hear that, if your CSV is formatted with columns in the wrong order, when you import it, it will allow you to map the data correctly so that you don't accidentally map, offset to receive frequency. All right, you have a radio, you know how to key it up, you know how to program it, you've filled it with memories. You filled it with frequencies in the memories. Let's use it. Here are some general operating categories. The first and simplest is, does this damn thing work? Well, tune up to a repeater, identify yourself, and ask if someone can give you a signal report. It's that simple. Chances are, if you get on any of the Rochester area repeaters, someone else is also there. And if you say something simple and you ask for something, like a signal report, can you hear me? Someone's pretty likely to come back and give you the simple answer, yes. And look, you've just operated. You've made a QSO. Traffic nets. Repeaters are really busy during common commute times. It's a great opportunity to find out which repeaters are busy, hear people, and potentially join in. And I say potentially because we should also use some etiquette. If there's 2 people clearly in the middle of a conversation, and you just want to say hi, and you don't know these people, maybe hold it. Maybe wait until a gap in their conversation or the topic changes or something. And at that point, it's appropriate, during a quiet time, to just send your call sign. KB1POP, just a pause. And chances are, one or more of the people in the QSO will respond to you. If they don't be offended, wait a little bit and try again. But you don't want to be barging in on people's conversations because you wouldn't want them doing that to you. Rag chew is exactly that. You get on and you talk about whatever. You got to find someone for it. Again, that's one, much like a radio check. If you get on a repeater, you'll probably find someone. I'm going to get into actually the conversations in the next slide. And the last major operating opportunity is to volunteer. Volunteering does 3 great things, 2 great things. One, most of them don't require special training, so that's the easy part. 2, we give you relatively simple instructions. Go here, do this, whatever. You get exposure, you get experience on the air, and you get to do public service. You're contributing to the community, which is part of the mission of amateur radio and of RARA. And we'll talk a little bit more about what operating in those events looks like. But first off, we'll go to the basic, before we get to events, just a basic first or early QSO. One initial way to try is just to key up a repeater and identify yourself. You can just key up and KB1POP monitoring. And a lot of times, if there's someone else there, they will respond if they're interested in talking right now. The other thing is when you unkey, you should hear the squelch on your radio open for a little bit, little at the end. That squelch tail, that tells you you're reaching the repeater, that you've opened the repeater, and that means the repeater has repeated you. Let's say you get on the repeater and you KB1POP monitoring and you wait 30 seconds and nothing. All right, well, let's try something else. There are mixed responses on whether or not you should call CQ on a repeater. A lot of people think it's frowned on, other people think it's not. This quote from Gary, KN4AQ, Gary claims to have, at least in a historic version, written the chapter on repeater operation for the ARRL, and he says calling CQ on the repeater is fine. So I've amended his statement by taking out a little of the CQ at the beginning. But his example is to call out CQ, anyone around. This is, I'm going to use mine because I can't read his fast enough. This is KB1POP, Kilo Bravo 1 Papa Oscar Papa. The name here is Tim. I'm in New Hampton, Rochester, and I'm looking to make a contact. KB1POP standing by. Now, why do you say all that? Well, there's a couple things. One, when I'm driving along, my radio is scanning through all the local repeaters. So if you just say KB1POP monitoring, chances are my radio scanning is going to miss you. But if you keep the repeater keyed up for 15 seconds, my radio is going to loop the scan and eventually it's going to lock onto you transmitting. So one, talking more makes you heard. For anyone that operates HF, that's the same rules for trying to call CQ and HF. And part two of the detail here is most hams are nice people. And when you say, I'm new and I'm trying to get into this, it implores someone to help you. And instead of just saying monitoring, I'm here, if you say, hey, I'm Tim and I really need some interaction, you're more likely to compel someone to help you out. So say someone responds, hello KB1POP, this is KC2WHR. Their call back to you is going to come in the format, your call sign and their call sign. And then I would consider thanking them for coming back to you. Hi, KC2WHR, thanks for responding. Where are you located? Are you traveling? Are you mobile? Ask anything. I put where are you located here because it's an easy one, right? So we operate in Rochester, but some of these repeaters have great coverage. Oh, I'm in Irondequoit. Oh, that's cool. I live in Irondequoit too, right? So you can have any simple conversation. You can continue a Q&A type thing in this format. And when you're done, you just say, hey, I've got to go. 73s. KB1POP from KC2WHR. In this case, the other person, right, I'm KB1POP, the other person has just ended the QSO, or indicated the end. And I can do one of two things. I can either say KB1POP listening, which means I'm still here, I'm monitoring, I'm looking for more chatter, or you can say KB1POP clear, which means I'm also going to leave, or at least I'm still here, but I'm leaving the repeater for other people to use. I'll be quiet now. And that's it. So it's that simple. Your first QSO can be get on a repeater, you call, you respond, and you close the conversation. So 3 little chats, and I put text in here as samples so that when you get on the air and you key the microphone and you go, ooh, I really don't know what to say, the words are right here. Just put your call sign in. All right, operating in a net. There are lots of kinds of nets. I'm really gonna focus on when you're doing public service, because that's one of the things we do here, and it's a great operating opportunity for development and getting on the air. In public service nets, in public service nets are typically directed nets, which means there's a net control, someone sitting somewhere that will tell you when it's your turn to talk. If they haven't told you it's your turn to talk, mostly don't. I say mostly don't, and we'll get into that in a second, but the idea is to keep the air available for important messages. The other part is that you'll get a tactical call sign. So I put safety in this example, but I'm not used to saying that because in most events we have SAG vehicles, support and gear. So you might get SAG 1. Or if you're on the 60-mile route, you might get 6 SAG 1. So that will be your tactical call sign. And if net control needs to get to you, net control says 6 SAG 1 from net control, and then they expect you to respond. That's your cue, that's net saying it's your turn to talk. Or the other way around, say you have some important thing. Net control, this is 6 SAG 1, and then you wait for them to tell you you can talk. So that's what I was saying about you mostly wait for them, but sometimes if you have something important to say, you have to say it. Keep the messages concise. All right, I have someone here that needs transport, we're at intersection X and Y. If they need medical attention, describe it. Beyond that, net control doesn't care what the weather is. Net control doesn't care what color the bike is. Let net control do their work and get back to you, and they'll send someone. Again, the idea is to keep the airwaves clear. Some people get excited during a public service event. They just want to use their radios. And we're excited for you to use your radio too. I worked net control for Tour de Cure this year, and sometimes there are so many people that net control needs to talk to that the conversations have to stay really short, or people keep calling in because they're not getting answers to their questions. Oh, look, I even had an example here. That's the example I just cited, but I didn't put it up here. All right, and then you say the last part of that is it is still important as an amateur radio operator to identify. So you start your conversation with your tactical call sign and you end it with your real call sign. So 6 SAG 1, I need something, and then at the end, understood, we'll stay here until the support vehicle arrives. So that's telling that control that you actually understood them by repeating the whole thing back. KB1 POP monitoring. Sometimes people leave off that tail when it gets busy, but the right thing to do is identify at the end of your transmission. Any questions or comments on operating?
No one to go over the proper use of over or out.
Whoa.
Because in a directed net, that's kind of important.
Yeah, I was just thinking about that. I don't know if we really did in Tour.
Really?
Yeah. Well, over means I'm done, and out means I'm really done. Okay?
That's pretty much it.
Over helps communicate to the other end that you have, it's like this page intentionally left blank. It says, I'm really done. Well, I'm really done with this sentence, and it's now your turn. Out is, I'm done with this sentence and I'm done talking to you. Good day, sir.
I don't know, I learned this stuff a million years ago. What I was taught was that over meant I am done transmitting and I expect a response. Out means I'm done transmitting and I don't expect a response. As an example of out, it might be, I need to go check that, wait 1 out.
That's
Not
great.
saying
I'm going to
I'm
repeat
done.
that because that's a better example. Over is, I'm done and I expect a response. What's the address? Over. Wait for them to give you the address back so that you can whiz along and support. Or, in your case, I'm not expecting a response. I will go to that address out. As in, I've told you what I'm doing, and we don't have to talk anymore for now. Thank you for bringing that up, and I'm obviously not good at using those.
Another good example is when you're checking into a net. When you're checking into the net, you will use over because net control will read back all the call signs that have checked into the net. So that's the response back. If you're rogering for the message, you can use out because you're not expecting a response back from net control.
Thanks. No, seriously. I mean thanks seriously, because I obviously didn't put it in here, and
Another thing is including the priority traffic. If there's an emergency or something, making sure that you mention it immediately upon seeing priority traffic, and so that you can cut in.
yeah. So when you're calling, especially if it's busy, and there are times I can just picture myself sitting in the car just waiting for someone to stop talking. If you have something, 6 Ag 1 emergency traffic or 6 Ag 1 priority traffic, and that lets net know that you're the most important caller because they might have a queue of people they're trying to get back to. It also lets everyone else on the repeater know that you're the most important caller. I'm going to put that in here too.
Don't believe Hollywood when they use over and out.
Yeah, and don't use break either. All right, the next few slides are going to be contentious. Oh well. What radio should I buy? So we talked about all of the how to use, but we get asked this question a lot, and I want to try to provide some guidance. The most important features, almost every repeater around here requires to get into. There are a few that don't, or some that will take tone, or a really strong signal without tone. And have enough power. If you buy an HT with 1 watt, you're not doing much. It's great if you live on RIT's campus and you want to talk to the giant antenna on top of the tallest building at RIT. Other than that, it's not enough. And if you think about people who ever buy FRS radios, the ones you buy at Walmart, and they say 5-mile range, and you can't talk to your neighbor, well, that's what it's like buying an HT that has 1 watt. There's a bunch of other nice to have stuff here. I'm not even going to get into it because we've already covered them. Mobile or HT. HTs are convenient. You can put them on your belt, you hold them in your hand. Most of the public service events require a mobile. Because most of our public service events involve bikes going very far. And when you're on the 100-mile bike route, it is, in many cases, not possible to reach the repeater on a 5-watt handheld. Now, I'll put a caveat in there. You can tell, well, really Mike, or the event captain, what equipment you have. If you have a handheld and you don't want to go out and buy a mobile, get a mag mount antenna, put that on your roof, and then tell the person running the event, I need to be near the repeater. I need to be closer to home. Don't put me on the 100-mile route. And you'll still be able to work. So it depends on what you want to do. Again, handhelds are great. Mobiles have a lot more power, and they'll help you, help RARA, and help the community. So there's a pitch. Brand. Ev put an article with a personal experience in this month's RARA Rag, and the article reads like this. I bought a Baofeng and I was really excited and it didn't work. They do work, but to an extent, you get what you pay for. Higher-end radios will have better audio in both directions. They'll have better receive rejection, which means that you won't hear as much garbage, and because of that, you'll be more likely to hear stations that are further away, and are often packaged with higher quality batteries. The top brands, from my personal experience and some quick web reviews, are Kenwood, Yaesu, and ICOM. Does anyone have anything that they think goes in the top brand category?
Alinco.
Yeah, so I was on the fence about that because I didn't have any experience, I didn't want to put it in. But I will put it in now because one other person said it. Good.
They've come a long way as far as quality control, quality in general. It certainly is much, much better than it used to be.
Yeah, I would agree with that. I've even seen a change in the I presume Wuxin and Baofeng radios in the last few years. If you do buy one of these so-called cheap Chinese radios, make sure that it's really appropriate and actually legally required that it carry an FCC. The radio is FCC licensed? Certification, thank you, that's the word I was looking for. So some of these vendors, like Redivis, will actually, in all of their Amazon ads, place a link to a copy of their FCC certification, assuming that that is not totally bogus. So they do work, they just don't necessarily work as well in as many adverse conditions. And what I just said about certification, some of them don't have certification, which makes them technically legal to operate because amateurs have a lot of exceptions, but you don't want to mud up the amateur bands with radios that generate a lot of spatter. Yeah, so there's a lot of these that you'll see, you'll go, wow, that one looks like the other one. They get rebranded. I bet if you were to look at the Baofeng radio and do a Google image search of it, you would probably find 4 other brand names that have something that looks identical.
If you buy enough radios from Baofeng, they'll stamp whatever model name and model number you want on it.
And I'm not accusing any of the companies on here of it, but it is important, I think, to know about the people who put their time and engineering effort into radios, that China does not respect patent law or copyright law. So a lot of these radios come cheap because the companies do know R&D, they just steal the design, reverse engineer it, and mass manufacture it. So that's part of the reason to buy from a reputable brand, is to support the engineering efforts that go into it. Again, I'm not accusing any of these brands. In general, a lot of electronics from China are patent infringement. What's next? The lights are out in the lobby. Weird, let me distract you all. There are lots of advanced VHF stuff. EME, Earth, Moon, Earth. You get a big Yagi antenna, and you point it at the moon, and you talk. And then people elsewhere on Earth that you can't see can also point their antenna at the moon and hear you. It actually blows my mind. It's pretty remarkable. The International Space Station. I have not talked to the space station, but I did stand out behind RIT and point a handheld Yagi at it and hear them. Just a white dot crossing the sky, and you point it up there. Pretty cool stuff. Satellites are kind of like both of those, well, really like the International Space Station. Microwave, we had a presentation in here from Jared, whose call sign I cannot remember, about operating 47 gigahertz and doing things that maybe we don't think you can do. So we think about HF as bouncing around off the ionosphere. Some of these really high microwave frequencies can do the same thing. And digital mode. So everything I've talked about has been focused on FM voice. FM voice and 70 centimeters and 2 meters is the most popular technician modes and bands. But there are other things you can do. So digital, there's all kinds of digital modes that I'm not going to cover. If you're interested in these, go ahead.
I'm just going to add one more. It happened last year, a high altitude balloon launch.
Oh,
With slow scan TV over FM voice.
Thanks for bearing with me. I'm really trying to enhance this before we publish it. The Rochester VHF group does a lot of these advanced things. They don't do a lot of repeaters, and that's okay. They want to focus on all this other stuff. We don't have, go ahead.
You can throw APRS in there too.
Yes. We don't have it ironed out yet, but we're going to do something where we collaborate with the Rochester VHF group for RARA Academy and cover one or more of these advanced operating opportunities. As we were talking to them about it, there were a lot of outdoor suggestions, so look for something in late spring. We were going to try and do a VHF beginner presentation and then an advanced VHF RARA Academy, but we didn't really feel like the December holidays were the best time to schedule a RARA Academy, which is why you'll notice the next one is in February. At the end, I put links to all the stuff that I borrowed, and links for, this is really just citations, links for anything that you want are live in the presentation and will be in the subsequent PDF. And with that, I am done, so I will take any extra questions or comments.
Where will you put this on the web?
That's a great question. I'm just trying, I've clicked on it, I can see it in my head. Whenever you go to select, I think on the upper right, it shows whatever presentation is next. If you click on that, it will take you to the page where we have the archive of all the presentations. So any presenter that will give us their slides, we put up there.
Thanks.
Well, half the room's extras, so I think that a lot of that was a lot of recap, but you also didn't all pipe up and tell me I'm wrong, so I think we did all right. Thank you. Yes, Mike?
I've used Q codes at the dinner table. Is that rude?
I guess it depends on if you just sound like a crazy person or if all your family are amateurs. Probably just sound like a crazy person.